So guys, there is one more problem here. But where is the problem? I only have this diagram, okay, and the diagram has got trajectory of this projectile. Uh, the initial speed is u and the angle of projection is theta, correct? And then it is finally landing at point A. So with usual notations, I would say starting point is O and it lands back on the ground at point A. This B I'm not marking at this point of time because it is not going to be used anywhere here, okay. But now the thing is that this projectile is fired such that it just crosses maybe this mountain, and P is the peak of the mountain. This projectile just crosses this peak of this mountain, okay. And uh, and when you connect this point P with your starting point and your landing point here, okay, and this angle made by this PO with the horizontal is alpha, and angle made by this PA with the horizontal again it is beta, okay. Now comes the problem, okay. We need to find out the relationship between this angle theta and angle alpha and angle beta. Now obviously uh, you know uh, no values have been given, okay. You have been given the angle of projection, okay, that is theta. You can take it as good as some value, okay. Then initial velocity you have, okay, and angle alpha and beta. But then angle alpha and beta, they can assume any value, right? Now this point P can be here or it can be here or it can be here, okay. And I said that there is some relationship between this angle theta and alpha and beta, okay. So if I say that, it must be there, right? You have to trust me on this, okay. So alright, so I'm going to mark my range here as maybe like this here. I'll use some other, and so this is my range, I would say R, horizontal range. Now what? I have this point P here. I'll call this point X comma Y. Okay. So obviously if I draw a perpendicular here, length of this perpendicular would be Y, and if O is my origin and X comma Y are coordinates of P, then this distance would be X. Then obviously this would be, now R you know, right? R we know. So I would say this remaining distance would be R minus X. Okay. Now what? Y is something common over there. Okay. I have this angle. So I have two triangles OP. I would call this Q. So OPQ and APQ. Okay. I'll write tan alpha equal to, tan alpha is equal to Y upon X, and tan beta would be Y upon R minus X. Now here, now since I have written this problem, I know that I have to prove that tan theta is equal to tan alpha plus tan beta. Okay, to prove that. Okay, or then the problem could be such that find the relation between alpha, beta and theta. Okay, now when I have this relation here, when they say show that that makes your work easier. Okay, so now first step that I would do here, I would find what is my tan alpha plus tan beta, correct? So tan alpha plus tan beta would be equal to Y upon X plus Y upon r minus x, and that would be equal to, now I am going to cross multiply and take LCM in the denominator there, and that is going to be equal to x into r minus x, and that would be yr minus xy plus xy. So I am going to be left with only yr here. Correct. So that is equal to y upon x into r upon r minus x. Okay. So this is my tan alpha plus tan beta. Number 1. Correct. Now, what about the equation of trajectory? Equation of trajectory is something like y is equal to x tan theta minus half, okay, into g into x square upon u square cos square theta. Okay, I remember. Okay, fortunately or unfortunately, I remember this formula, and this is the equation of trajectory. Alright, so let's do something here. I'll take x tan theta common here. Okay, so it would be x tan theta into 1 minus, okay, I don't have any tan theta there. I do have x there, so it would be half as it is there. Okay, I have taken 1x here, so I would have g over there and x. What about here? It would be u square cos square theta. Okay, and then I'll take tan theta down. Okay, you can check again. So if you open this bracket, if you expand this, it will be x tan theta minus g x square tan theta upon 2 u square cos square theta tan theta. So that tan theta is going to get cancelled. So what you are going to be left with is what I had here. Okay, so I have taken only x tan theta common. Okay, what do we do next? Alright, so x tan theta. Now this u square cos square theta into tan theta. I'll do one thing here. I'll just work this out here. Okay, cos square theta into tan theta. Okay, I also have this 2u square, right? 2u square cos square theta into tan theta. That would be 2u square cos square theta into sin theta upon cos theta. Right? Can I cancel one cos theta? I can. Okay, so this square sign is gone and one cos theta is gone. Correct? So I have 2u square sin theta cos theta, and if I take this 2 sin theta cos theta, that would be u square sin 2 theta, isn't it? So it is u square sin 2 theta. Okay, so I'll just add that here now. It is 1 minus g into x upon this whole thing. I'll write as u square sin 2 theta. Correct? Alright, what was my formula for range of projectile? Was it not something like this here? My r is equal to u square sin 2 theta upon g. Correct? So u square sine 2 theta upon g is my r. So g upon u square sine 2 theta is nothing but 1 upon r, isn't it? So I'm going to have this as x tan theta into 1 minus x upon r. Can I say that? Yes, I can. So now what do I do here? Okay. So this will become x tan theta into, so r minus x upon r. Okay, and that is nothing but my y here, right? So now I'll keep tan theta, only tan theta on the right hand side, and rest everything I'll take on the left hand side, correct? So that implies y by x into r upon r minus x is equal to tan theta. So only tan theta is kept on the right hand side, right? Now this is my expression number 2. Now if you see expression number 1 here and expression 2 here, is it not same? So right hand side of this and left hand side of this, they are same. So what can we say from this? So I'm going to erase this. You can play the video again and see it or then read it. So I'm going to write here, so from 1 and 2, from 1 and 2 I can say that tan theta is equal to tan alpha plus tan beta, and this would be true for any values of alpha and beta. Okay, your p can be here, or it can be here, or it can be here, or here, anywhere. Okay, along the trajectory, when your projectile is just crossing a point, okay, just crossing peak of maybe a mountain or a building or whatever you call it, okay, this relation is always going to be true for a projectile. Thank you so much.